Hello everyone and welcome to this complete course on MCP in .NET 9. My name is Navin Gimire and in this series we will be building AI applications using the Model Context Protocol. If you have heard about MCP but aren't sure how it fits into real-world .NET projects, this course is designed exactly for that. We will focus on practical examples connecting AI assistants to data sources, APIs, and tools using .NET 9, not just theory or demos. By the end of this course, you will have a clear mental model of how MCP works and the confidence to use it in your own application. So put on your headphones, open your editor, and let's get started. The problem we are facing today. This looks like a mess, right? Because it is. Imagine you are building an AI agent in .NET. You want it to query your SQL Server database and maybe check a few internal APIs. To do this right now, you have to write custom glue code. You are manually building the tool definition for OpenAI, then maybe rewriting them for Anthropic. You are handling the authentication headers, the JSON serialization, the error handling, and many more, specifically for that one connection. Then your boss asks, hey, can this AI also read the logs from the file system and maybe summarize these PDF reports? Suddenly, you are writing more custom logic. You are essentially hard coding pipelines between your specific data and a specific AI model. But here is where it breaks. What happens when you want to swap the AI? What if you want to use Cloud Desktop instead of your custom Python script or use the Cursor IDE? You can't because all that logic you wrote is trapped inside your application. The database can't talk to cloud on its own. The file system creates a security risk if you just paste everything into the prompt. We call this the M by N problem. You have M number of AI models trying to talk to N number of data sources. Trying to build a bridge for every single combination creates this spaghetti diagram. It is unmaintainable, it breaks constantly, and frankly, as a developer, it is just a waste of our time. There has to be a standard way to unplug these wires and make them plug and play. And that is exactly what the Model Context Protocol solves. This is where MCP comes in. MCP stands for Model Context Protocol. The best way to understand it is with an analogy. Think of MCP like USB for AI. Before USB, if you wanted to connect a printer, you needed a parallel port, a mouse, a PS2 port, a modem, a serial port. Every device needed a custom physical connection and a custom driver. It was a headache. Then USB arrived. It provided one standard plug for everything. MCP is exactly that, but for large language models. It provides a standard plug that lets AI connect to any data source without needing custom code for every single integration. Let's look at the architecture. It was created by Anthropic and is completely open source. On the left, in blue, we have the AI assistant and the MCP client. It is important to understand the distinction here. The AI assistant is the brain, usually a cloud model like Cloud 3.5 Sonnet. The MCP client, sometimes called the host, is the application you are actually using, like the Cloud Desktop app or the Cursor IDE, or maybe a custom chat interface you built. The client is responsible for maintaining the connection and deciding when to ask for help. Now, look at the green side. This is where the magic happens. And this is what we are going to build in this series, the MCP server. In our case, this will be a .NET 9 console application or web API. The server's job is to define the tools and resources. It tells the AI, hey, I have a tool called getUserById and I have a resource called system logs. The server sits right next to your data source. This could be your local file system, a Postgres database, or a protected internal API. Because the server runs locally or within your private network, it keeps your data secure. You aren't uploading your whole database to the cloud, you are just providing the AI a controlled way to query it. And finally, look at those arrows connecting the blue and the green. The client and the server talk to each other using JSON RPC. It's a lightweight, stateless protocol. It usually runs over STDIO, standard input output, meaning the client literally spawns your .NET app as a SOAP process and talks to it via the console, or it can run over SSE, server sent events for remote connections. So the flow is the AI has a question, it asks the client asks our .NET server, our server queries the data source, and the answer flows all the way back up the chain. It's elegant, standardized, and thanks to .NET 9, it's incredibly fast to implement. But abstract boxes and arrows are a bit boring. You are probably wondering, okay, but what can I actually build with this? In the next section, we will look at three real world use cases. Let's make this concrete. We know the theory, but what does this actually look like when you sit down to code? Here are the three real world examples of MCP servers you might build. First, the file system server. This is the hello world of MCP, but it is incredibly powerful. Imagine building a .NET server that exposes a specific directory on your computer's, say your source code folder. You can give the AI a read tool and a write tool. Now, inside Cloud Desktop, you can say, hey, look at my program.cs file and refactor the logging logic. The AI uses your tool to open the file, reads the content, writes the new code, and saves it. You didn't copy paste anything. It just happened. And because you wrote the server code, you can restrict it. You can say, only allow access to the safe zone folder. You have total control. Second, and this is my favorite, the database server. As .NET developers, we live in a SQL Server or Postgres. Usually, if you want to ask questions about your data, you have to write a SQL query, run it, export the results to CSV, and upload that to the AI. With an MCP server, you wrap your entity framework context or Dapper queries in a tool. You expose a tool called run read only query. Now, you can ask the AI who were the top 10 customers last month and what did they buy. The AI understands the schema, generates the SQL, sends it to your .NET app. Your app runs it against the DB and returns the JSON. The AI then formats that into a beautiful chart or summary. It's like having a data analyst sitting inside your IDE. And third, actionable tools like an email server. MCP isn't just for reading data, it's for taking action. You can write a sysap method called send email. When you connect this to the AI, you can say, draft a reply to this client and send it. Now, usually this is scary. You don't want AI sending emails automatically. But because you control the client, the AI will pause and ask for your permission before executing that tool. This is the concept of human in the loop, and MCP supports it natively. The possibilities are endless. If you can write sharp code for it, you can turn it into an MCP tool. So, whether it's managing files, querying data, or automating workflows, MCP gives you the standard way to build it. Before we jump into the code, let's make sure you have the right tools in your toolbox. The requirements are pretty standard for modern .NET development. First, you need Visual Studio 2022 or later. If you prefer VS Code or Rider, that works too, but I will be using Visual Studio. Crucially, you need the .NET 9 SDK installed. We are going to leverage some of the latest features in the base class library, so make sure you are up to date. I have put a download link in the description, and obviously, you need basic C# knowledge. You should be comfortable with classes, interfaces, and dependency injection. In terms of concept, here is what will help you the most. First, async and await. MCP relies heavily on asynchronous communication. We are talking to external processes, after all, so we will be writing a lot of async code. Second, a basic understanding of JSON. Remember, the P in MCP stands for protocol, and that protocol is just JSON messages flying back and forth. And finally, basic HTTP concepts will help when we get to server sent events transport layer. But don't worry, if you know your way around a console application, you are ready to start. Now, let's get everything installed. Alright, let's get our environment ready. We are going to start fresh. First, if you don't have it already, head over to visualstudio.microsoft.com and download Visual Studio 2022 or later. You can absolutely use the Community Edition. It is completely free for individuals and open source work, and it has all the features we need for this course. While that is installing, we need to make sure we have the latest SDK for 9 version. Visual Studio usually includes it, but let's be certain. Go to the .NET.microsoft.com, navigate to the download section, and look for .NET 9. You want the SDK Software Development Kit, not just the runtime. The SDK allows you to build apps. The runtime only allows you to run them. Download the installer for your OS, Windows, Mac, or Linux, and run it. It's quick install. Before we open Visual Studio, let's do a quick sanity check to make sure the installation actually works. Open your command prompt or terminal. Type .NET list SDKs. So you should see 9 version listed there. If you see that, you are golden to go. If not, you might need to restart your computer. Now, open Visual Studio, click on Create New Project. In the search bar, type console app, select the C# version, click Next or double click. You can name it Test MCP. We are going to delete this later. We just want to check the framework. On the next screen, look at the framework drop down. You must have .NET 9. Select that and click Create. If the Visual Studio loads up and you can see console.write line, then congratulations. You are ready to go and your environment is perfectly set up for MCP development. Now, before we write our own code, let me show you what the final result will look like. Before we start coding from scratch, I want to show you the finish line. This is the MCP client we are going to build. Look at the code. It follows a strictly typed linear flow. We connect, initialize, discover the tools, then use them. Let's run this and watch the handshake principle happen in the real time. Let me run the app. Let us watch the console. The server is connecting, the client is connecting to the server. So it finally gets connected. Look at the JSON output after it will be initialized. The server responds with its capabilities. It tells us I am the test server and I support these protocol versions. Now we call the list tools and it provides us with the available tools it has. It responds like I have an echo tool and I have a calculator tool. It even defines the argument required. This is how the AI knows strictly what it is allowed to do. Now the execution. Finally, we put the tool to work. In step 4, we send a simple echo with message hello MCP. The server reflects it back. But step 5 is the real use case. Look at the code again. So in step 5, we are sending a dictionary with operation add A as 15 and B as 27. We send that to the server. The server processes the logic and boom, it returns the result 42 in the console. We didn't write any custom parsing code, we just call tool async. And that is the beauty of this library. Look at how clean this setup is. Await client.connectAsync, await client.listToolAsync, and await client.callToolAsync. It feels just like using HTTP client, but structured specifically for AI interaction. We are going to build this wrapper step by step so you can drop this into any .NET application you have. Are you ready to write this? So you have seen the demo, you have seen the power of MCP. Now it's time to build it. In the next part, we are going to write our first lines of code. We are going to build a console client from scratch. We will connect it to a dummy server. We will inspect the JSON messages manually so you understand exactly how they work. And we will send our very first ping request. But before you go to the next section, I have a little bit of homework for you. I need you to be ready to code along with me. Make sure Visual Studio 22 is installed and updated. Double check that you have the .NET 9 SDK. Go to the link in the description and clone the GitHub repository for this course. I have created a starter branch and a final branch. Download the code now so you have it ready on your machine. This series is going to be fast-paced and very technical. If you want to master AI integration in .NET, make sure you hit that subscribe button and ring the bell. You do not want to miss next video. I'm incredibly excited to teach you this. This technology is changing how we build software, and I'm glad you are here to learn it with me. Get the environment ready, grab a coffee, and I will see you in the next video.